Hi everyone. Today we are going to deal with the topic asynchronous counters. It is from fourth module of digital electronics. So in the class we have already covered the synchronous counters, which are up counter and down counter. Okay. So in up counter, we need to okay. Up counter, we have already told what is up counter and what is down counter, and then also we have explained what is asynchronous counter and what is synchronous counter. Okay, so no more explanation on that. We are directly going to asynchronous counters. In asynchronous counters itself, we have uh, two types, up counter and down counter. Up counter is the one which counts up, that is 0 to higher orders, 0, 1, 2, 3, 4, like that. And down counter means it counts in descending order, at the largest number to lowest number. Okay. Then in that asynchronous counter, up counter circuits and down counter circuits we have already discussed. And today, or in this lecture, we are going to discuss about mode mode n counter or truncated counters. Okay, so before going to truncated counters, we need to know that what is mean by the modulus of a counter, or that is modulus of a counter or mode of a counter. Modulus of a counter means it is nothing but the number of output states of a counter. Okay, that is if we are considering a 2-bit up counter, we know that there will be 2 bits. So that counter can count from 0 to 3, that is 0 0 0 1 1 0 and 1 1. 1 1 is nothing but 3. Okay, so it can count 0 1 2 and 3 up to 3. That means there are 4 different states or 4 output states are there. First state is 0 0, second state is 0 1, third state is 1 0, and fourth state is 1 1. After 1 1, it will again reset to 0 0, and same stages or states will be continued. So there are 4 distinct stages or states in that 2-bit up counter. So the modulus of that counter is called, or modulus of that counter can be say as 4. Okay, modulus 4 counter or mode 4 counter. Okay, then if we are considering a 3-bit up counter, a normal 3-bit up counter, there will be 3 output pins and there will be 8 states. That is, it can count from 0 to 7. That is 0, 0, 0 up to 1, 1, 1. 1, 1, 1 is nothing but 7. So there will be 8 states, that, or 8 stages. 0, 1, 2, 3, 4, 5, 6 and 7. That is 8 states. That means the modulus of that counter is 8. Okay. Then, which means that there will be 2 raised to n states for any counters. That is for a where n is the number of flip-flops used or number of bits. Okay. So for a 2-bit counter or 2-bit up counter, we are using 2 flip-flops and there will be 2 raised to 2 states where that is 2 raised to n states where n is the number of flip-flops used or number of bits. Okay. So in 3-bit up counter, we are using 3 flip-flops and there will be 2 raised to 3 states, or modulus of that counter will be 2 raised to 3, which is 8. Okay. Then next is truncated counters or mod n counters. Mod n counters or truncated counters means uh, there will be, or that counter can count uh, up to a stage which is less than the maximum possible number of states. That is, if we are using 3 flip-flops in a counter, we can maximum count up to 7, or there will be maximum possible states are 8. But in truncated counters, there will be 3 flip-flops used, but it can count only up to a number less than 8, or there will be states only less than 8. That means if that counters are called truncated counters. For example, there are 3 flip-flops used, and a counter can count only up to 5, 0 to 5. That is, there will be 6 states, but 3 flip-flops are used. Okay. Such counters are called truncated counters and depends on its mode, number of states or modeless. That counters can be called as mode 6 counter, mode 10 counter, mode 12 counter, or mode n counter. Okay, how many states are there in that counter? That number is called along with that the word mode. That is why mode 6 counter, mode 10 counter, ripple counter is nothing but the asynchronous counter. So mode 6 asynchronous counter, mode 10 asynchronous counter, and also mode 12 asynchronous counter. So mode 6 counter means there will be 6 states, or it can count from 0 to 5. 0 to 5 means there are 6 stages or states. In mode 6 counter, we need to use flip-flops, 3 number of flip-flops, because to count 0 to 5, 5 to represent the number 5, we need 3 bits, right? That is 101 is the representation for the number 5. So to represent the number 5, we need 3 flip-flops or 3 bits. 3 bits, to represent 3 bits, 3 flip-flops are used. Okay, needed. So 3 flip-flops are used, but it cannot count up to 111. Or its states are limited to 6. Or it can count from 0 to 5. Such counters are called truncated counters. Then, similarly, in the case of mode 10 counter, it can or it has 10 distinct states, or it can count from 0 to 9. To count up to 9, we need how many bits? To represent 9, 9 is nothing but 1001. 4 bits are needed, which means 4 flip-flops are used here, but the maximum number of states with 4 flip-flops are actually 2 raised to 4, 16. But here the states are reduced or cut into uh, uh, or the number of states are limited to 10. That is why the counter is called what mode 10 counter. So the mode 10 counter can count from 0 to 9. Clear? Then like mode 12. Just like mode 10, mode 12 can count up to 0 to 11. That is, there will be 12 states. They can count from 0, 0, 0, 0 to 12 means 1, 1, 0, 0. Okay. Sorry, not 12, 11. 11 means 1, 0, 1, 1. Right. Okay. So it can count 1, 0, 1, 1. Up to 1011, there will be 12 states. So for count up to 11, 4 flip-flops are needed, but the maximum possible count with 4 flip-flops are 1, 1, 1, 1 or 15. But here the count is limited to 12 or 0 to 11. Clear? So such counters are called truncated counters. Okay. Then first, we are explaining about the decade counter. Decade counter is nothing but mode 10 counter. Decade means the number dec means 10. Okay, so mode 10 counter is also known as decade counter. Okay, so mode 10 counter means there will be 10 distinct states, or it can count up to 0 to 9. Right? 0 means 0, 0, 0, 0 to 9 can be represented by 1, 0, 0, 1. So there will be 10 distinct states from 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, just like 1, 0, 0, 1 up to 1, 0, 0, 1. Then how it is limited to or up to the count 9. It is we are going to discuss. So different states of a decade counter or mode 10 counter is 00000001 up to 1001. So this is the state table for the decade counter, and the circuit diagram is nothing but just like the uh, mode, sorry, just like 4-bit up counter. So 4-bit up counter means 4 JK flip-flops will be there. All the flip-flops will be in toggle condition, and the first flip-flop is triggered from an external clock signal like this. And the next flip-flops are triggered from the Q output of the previous flip-flop. Here we are using negative edge triggered flip-flop. So the Q is used as the clock signal for the following flip-flops. Okay. Uh, if it was a positive edge triggered flip-flop, we can use the clock signal as Q bar. Q bar need to be used as the clock signal. Here negative edge triggered flip-flops are shown. That's why we are using Q as the clock signal. Okay. Then just like next flip-flops are triggered by the previous output Q of the flip-flop. Okay. Then only change is that here we are using a NAND gate. This makes this counter as mode 10 counter. That is, actually without this NAND gate, this flip-flop can count from 0, 0, 0, 0 to 1, 1, 1, 1. But here we are using a NAND gate, and the outputs to the NAND gate are Q1 output and Q3 outputs are given to the inputs of an AND gate, and that output of that NAND gate is used to clear uh, all the flip-flops. Okay, that means so here actually um, the various states of the flip-flops are 1 second. Okay. So here various states are like this 0, 0, 0, 0 up to 1, 0, 0, 1. After 1, 0, 0, 1, it actually uh, count to the next state, that is 1, 0, 0, 1 and 1, 0, 1, 0 is the next state of this counter. So the circuit, there is no change in the circuit. It is just like a asynchronous up counter. So asynchronous up counter will count 1, 0, 0, 1. After 1, 0, 0, 1, the next state is 1, 0, 1, 0. So actually the state 1, 0, 1, 0 will come, but in 1, 0, 1, 0, the fourth bit and the second bit are sending to the NAND gate inputs അല്ലെങ്കിൽ or inputs of a NAND gate. So for this NAND gate, when the counter counts 1, 0, 1, 0, these two ones will be acting as the inputs for a NAND gate. So the output for a NAND gate will be 0 if and only if all the inputs to that NAND gate is 1. So when all the two inputs, that is fourth bit and second bit become 1, the output of this NAND gate becomes 0, and this 0 is sent to the clear input of all flip-flops. So whenever the output of this NAND gate becomes 0, all the flip-flops will be cleared. So the up counter will count 1, 0, 0, 1 after 1, 0, 1, 0. When the state 1, 0, 1, 0 came, the NAND gate output becomes 0, and that by that signal we are clearing all the flip-flops. So whenever the state 1, 0, 1, 0 came, at the same moment all the flip-flops will be cleared and the outputs become 0, 0, 0, 0. So after 1, 0, 0, 1, the states become 0, 0, 0, 0, 1, 0, 0, 0, 0 reached. The counter will again counts from 0, 1, 2, 3, just like that. Okay, so the circuit is like this. That is, just like an up counter, asynchronous up counter, and where we are included a NAND gate and whose inputs are connected to Q1 and Q3. ഓക്കെ. അപ്പൊ ഈ Q1 Q3 കണക്ട് ചെയ്യാനുള്ള റീസൺ ഇതാണ്. നമുക്ക് 9 വരെയാണ് കൗണ്ട് ചെയ്യേണ്ടത്. 9 എന്ന് പറഞ്ഞാൽ 1001. ദെൻ അത് കഴിഞ്ഞാൽ വരുന്ന നെക്സ്റ്റ് സ്റ്റേറ്റ് എന്ന് പറയുന്നത് 10 ആണ്. പക്ഷെ 10 കൗണ്ട് ചെയ്യരുത്. 9 കഴിഞ്ഞാൽ 0000ക്ക് പോകണം. അപ്പൊ അതിനായിട്ട് നമ്മൾ ചെയ്യുന്നത് whenever the stage 10 comes, the all the flip flops need to be cleared. അപ്പൊ 10 വന്നു എന്നുള്ളത് എങ്ങനെയാ മനസ്സിലാക്കുക? 10 എന്ന് പറയുന്നത് 1010 എന്നാണ്. 1010 എന്ന് പറയുമ്പോൾ Q3യും Q2, അതായത് ഇവിടെ ഈ Q3 1010 എന്ന് പറയുന്നത് എപ്പോഴൊക്കെ ഉണ്ടാവാം? ഇവിടെ 1010 ആണ് ഇതിന് ശേഷം വരുന്ന സ്റ്റേറ്റ്. 1010 വരുമ്പോഴത്തെ പ്രത്യേകത എന്ന് പറയുന്നത് Q3യും Q1ഉം 1 ആവണം. ബാക്കി മുന്നുണ്ടായിരുന്ന ഒറ്റ സ്റ്റേറ്റിലും Q3യും Q1ഉം സൈമൾട്ടേനിയസ്ലി 1 ആവുന്നില്ല. അത് രണ്ടും 1 ആവുമ്പോഴാണ് എന്ത് 10 എന്ന സ്റ്റേറ്റ് വന്നു എന്ന് നമ്മൾ പറയുന്നത്. അപ്പോൾ ഇത് രണ്ടും 1 ആവുന്ന സമയത്ത് നമ്മൾ എന്ത് ചെയ്യും? ഈ രണ്ട് ഔട്ട്പുട്ടിനും കൂടെ നാൻഡ് ഗേറ്റിന്റെ ഇൻപുട്ടിലോട്ട് കണക്ട് ചെയ്യും. നാൻഡ് ഗേറ്റ് എന്ന് പറയുന്ന ആള് ഔട്ട്പുട്ട് 0 തരിക, അതിന്റെ എല്ലാ ഇൻപുട്ടുകളും 1 ആവുമ്പോഴാണ്. അപ്പോൾ ഈ Q3നും Q1നും നാൻഡ് ഗേറ്റിലോട്ട് കണക്ട് ചെയ്താൽ ഈ 10 എന്ന് പറഞ്ഞ സ്റ്റേറ്റ് വരുമ്പോൾ മാത്രമാണ് Q3യും Q1ഉം ഒന്നിച്ച് 1 ആവുള്ളൂ. അത് രണ്ടും 1 ആയി കഴിഞ്ഞാൽ അറ്റ് ദ സെയിം ഇൻസ്റ്റന്റ് the output of the NAND gate becomes 0. Then output of NAND gate ആണ് നമ്മൾ ഇവിടെ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്സിന്റെയും ക്ലിയർ ഇൻപുട്ടിലോട്ട് കൊടുക്കണേ. സോ ക്ലിയർ ഇൻപുട്ട് എപ്പോഴെങ്കിലും 0 വന്നു കഴിഞ്ഞാൽ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്സിന്റെ ഔട്ട്പുട്ട് എന്താവും? 0. അതാണ് ക്ലിയർ എന്ന് പറഞ്ഞ ഇൻപുട്ടിന്റെ പ്രത്യേകത. നമ്മൾ ക്ലിയർ ആൻഡ് പ്രീസെറ്റ് ഇൻപുട്സ് നമ്മൾ പഠിച്ചാറുണ്ട്. ക്ലിയർ എന്ന് പറയുന്നതിൽ 0 വന്നാൽ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്സിന്റെ ഔട്ട്പുട്ട് 0 ആവും. പ്രീസെറ്റിൽ 0 വന്നു കഴിഞ്ഞാൽ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്പിന്റെ ഔട്ട്പുട്ട് 1 ആവും നമ്മൾ പഠിച്ചിട്ടുണ്ട്. അപ്പൊ ഇവിടെ എന്ത് ചെയ്യുന്നു? നമ്മള് 1010 എന്ന് പറഞ്ഞ സ്റ്റേറ്റ് വന്നു കഴിഞ്ഞാൽ ആ സെയിം ഇൻസ്റ്റന്റിൽ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്പിനെയും ക്ലിയർ ചെയ്യും. സോ 1010 എന്ന് പറഞ്ഞ സ്റ്റേറ്റ് നമുക്ക് അവിടെ കാണാൻ പറ്റില്ല. 9 കഴിഞ്ഞാൽ നേരെ എല്ലാ ഫ്ലിപ്പ് ഫ്ലോപ്സ് എന്താണ്? ക്ലിയർഡ് ആയി പോകും. 0000 തൊട്ട് എഗൈൻ കൗണ്ട് ഡൗൺ ചെയ്യും. ഓക്കെ. അപ്പൊ അങ്ങനെയാണ് ഈ മോഡ് 10 കൗണ്ടർ അല്ലെങ്കിൽ ഡെക്കേഡ് കൗണ്ടർ വർക്ക് ചെയ്യുന്നത്. സിമിലർലി ഇഫ് യു ആർ ടെല്ലിംഗ് അബൌട്ട് മോഡ് 6 കൗണ്ടർ, it need to count up to 6 or 5. 0000 to 5 means 1, 0, 1. Right. It will not count 6. It will count up to 0 to 5. So these are the different stages. And after 5, actually it will count 1, 1, 0. But whenever 1, 1, 0 comes, at the same instant, all the flip flops need to be cleared. So here the circuit diagram will be just like 3-bit up counter. 3 bits are used here. The circuit will be just like a 3-bit up counter. But again, a NAND gate will be used, and the inputs for this NAND gate should be this Q2 and Q1. Whenever Q2 and Q1 become simultaneously 1, it indicates that the stage 6. Okay. So whenever the 6 comes, the flip flops need to be cleared, and that should be reset to 0000. So 6 means 110. So 11, whenever the state 110 comes, Q2 and Q1 become 1. When Q2 and Q1 become 1, the NAND gate output becomes 0, and that 0 is used to clear all the flip flops outputs. Okay, that's why Q2 and Q1 outputs are connected to this NAND gate. Okay, whenever the 6th state comes, at the same instant, all the flip flops need to be cleared. Okay, so there is no change in the circuit of that up counter. Only change is that we need to include a NAND gate. In that, the inputs to that NAND gate will be set in such a way that the output of the NAND gate becomes 0 when the unwanted state comes. Okay. Then similarly, we can also design mode 12 counter. Mode 12 counter means it can count up to 0 to 11. 11 is nothing but what? 1, 0, 1, 0, 1, 1 is 11. So it will need to count from 0, 0, 0, 0 to 1, 0, 1, 1. And whenever the next state 12 comes means 1, 1, 0, 0 is 12. Whenever this 12 comes, the all the flip-flops need to be cleared. So in that case, we need to connect which all outputs to the inputs of NAND gate. Q3 and Q2 need to be connected to the inputs of NAND gate. And whenever Q3 and Q2 become 1, which indicates the state 1100. So at that instant, the flip NAND gate output becomes 0 and it will clear all the outputs of the flip-flops. So in the case of mode 12 counter, we need to use 4 flip-flops and NAND gate. To NAND gate, the inputs Q3 and Q2 need to be connected as the input to that NAND gate. Okay, this is mode 12 asynchronous counter. So these are all about the truncated counter. Okay. Thank you.